9.4, measure of variation. All right, to start this off, we'll talk about what measure of variation is. So the measure of variation is a measure that describes the distribution of a set of data. A simple measure of variation defined is the range. So what is the range? The range is a set of data. The range of a set of data is the difference between the greatest value and the least value. So in other words, we have to know what the word difference means because we're going to have our data, our least amount of data minus our greatest amount of data to end up finding what the range is. Okay, so finding the range of this, the table shows the lengths of several Burmese pythons captured for a study. Find and interpret the range of their lengths. So they give us all this data over here. What we're going to first start off with doing is finding the least and the greatest values, and then we're going to order the lengths from least to greatest, and it will look like this. So our least value happens to be 5, and our greatest value happens to be 18.5. So, and these are in feet. The range of the lengths is, we take our 18.5, we take our greater one, and we subtract it from our least. So the 18.5 minus 5 equals, remember we line up the decimals when we're doing this as side math, 13.5 feet. So this means that the lengths vary by no more than 13.5 feet. So that ends up being our range. Okay, so this can be a little tricky to understand, so make sure you're following along here. So the key idea, this is about quartiles. The quartiles of a data set divide the data into 4 equal parts. So recall that the median would divide the data set into 2 halves, and it would look something like this. So let's say this is our data. And basically what's happening is when we're finding the median, we're going through and we're going to find the middle values. And basically, if I were to do this all out, I would get rid of, and I would get down to the point where I'd have 2 in the middle. So 28 and 30. And then I would add those together and divide by 2, just like I learned in the last, in the last video. And then I would realize that my median happens to be 29. So what's happening is we're basically, where our median lies is where we're splitting our data into 2 halves. So then we have what we call as the lower half and the upper half. Okay, so this is our lower and this is our upper. Okay, so now what we're going to do is we're going to find the median of the lower half, and that would be called the first quartile, Q1, and then we're going to find the median of the upper half, which is the third quartile, Q3. I know it's a little confusing, just kind of follow with me here. So let's move over here to the lower half. So I'm going to start by finding the median. So I cross off, cross off, cross off, cross off, ends up with 22. Now I'm going to find the upper half. Cross off, cross off, cross off, cross off, 32. So what it's telling me is that my quartiles, I've got my first quartile. So far we've got our first quartile is 22, Q1. Our third quartile is 32, Q3. But what's our second one? We're kind of missing that. Our second one actually is just our median, because that's where we split them in the first place. So we split it, our median. So our median ends up being our Q2 in a way, if you want to kind of just know that that's our Q2. So it's actually pretty simple if you think about it. You've got your data. Number one, you find your median. Okay? So you take all your data, find the center one. If you have to do the dividing, you do it. After you do that, you take your lower half of your data, find the median. Okay, once you do that, you find your upper half of your data, you find the median. You might have to find the median because you have 2 even numbers over there and find it by dividing it by 2 again. That's fine. But now that we know this information, we can find the interquartile range, it's called, the IQR. I'm going to teach you how to do that. It's very simple. And here we go. Okay, so interquartile range, or IQR, it's known as. So we got the difference between the third quartile, which we call Q3, the 3 is kind of lower, and the first quartile, okay, so we got Q1, is called the interquartile range. The IQR represents the range of the middle half of the data and is another measure of variation. So we already learned about range. Now we're learning about the interquartile range, which is a different type of measure of variation. So we're going to use the same data, and then we're going to find out what the IQR would be. It's very simple, just sounds kind of confusing. Okay, so there's all my data again. Let's remember, looking back, that our first quartile, or a Q1, from our lower half was 22. And then our Q3 from our upper half, third quartile, was 32. All we did was we split this right down the middle, which is where our median left us. And then we found our upper, remember this is our upper half, this is our lower half. Okay, I'm just kind of as a reminder here. And now what we're going to do is we're going to find the IQR, the interquartile range. So to find the IQR, it says up here, the difference between the third quartile and the first quartile. Well, let's just do that. What is the difference between the first quartile and the third quartile? So we take the third quartile, Q3, so we'd say Q3 minus, because it's a difference, Q1. Now let's just plug in what those numbers happen to be. We got 22 and we have 32. This is my Q3, this is my Q1. So Q3 is 32 minus Q1 is 22. So my interquartile range happens to be 10. So it's just another measure of variation. I know it's time consuming and it's going to take you a second to realize what's happening. This is not something you just get with a snap of a finger. You have to really focus on it and think about it. Okay? So that's just another measure of variation. Example 2 is finding the interquartile range. Okay, so the dot plot shows the top speeds of 12 sports cars. Find and interpret the interquartile range of the data. So this dot plot here is showing us that we have a bunch of different cars going at a bunch of different speeds. So now what we're going to do is we're going to try and find and interpret the interquartile range by finding it. So here's how we do it. We would start with ordering the speeds from slowest to fastest, and then we're going to find the quartiles. Alright, so these are labeled, these are put in there from least to greatest in speeds. And what I'm going to do is I'm going to find the median to start, so I know where my center is, so I can recognize what my lower half and my upper half are. So I have 245 plus 250, and that ends up equaling, once I divide that by 2 as well, that ends up equaling 247 and a half. So right down the middle is my 247 and a half, which happens to be my split point, okay? So this is my upper half, and this is my, this one's my lower half. My bad. Oop, I gotta get my eraser here. Won't let me. Okay, so this one is my lower half, sorry. And this one's my upper half. So now I'm just going to do the process over again. I'm going to start with these numbers on my left-hand side over here. I'm going to find from these numbers here, including the 245 here, I'm going to try and find what is my median of those numbers. So I'm going to cross off, cross off. I'm left with 2. Do the same thing over here, cross off, cross off. Left with 2. They're not the same numbers, so they're going to be different numbers. So I have 230 plus 240, okay, and I'm going to divide that number by, or I'm going to get that number, then I'm going to divide it by 2. 470 divided by 2 ends up being 235. Do the same thing over here. Now I have 250 plus 260. I'm going to get 510. I'm going to divide that by 2, and I should end up with 255. So what I'm representing here is I'm seeing that I've got two different ranges that I need to find the interquartile range of. So let's take our Q3, which happens to be our upper half of, I'm going to do a different color just so it doesn't get all mixed up here. These are my, keep those over there. So I'm going to take 255 and I'm going to subtract it from 235 to find my IQR. my IQR happens to be a total of 20. So, the question said, find and interpret the interquartile range of the data. Well, if the interquartile range is 20, this means that the middle half of the speeds vary by no more than 20 miles per hour. And you can use quartiles and interquartile range to check for outliers if you really wanted to. So it's just kind of something to keep in mind as you're going, and I know it sounds confusing again, like I said, but just a little bit more practice with it and remembering. There's a lot of things to remember in this chapter, so keep on it. Make sure that you're studying. And this is the end of 9.4.